Welcome to the second series of this linear algebra, and we are continuing with question number 2, and we are to determine whether the matrix A is similar to B. Matrix A is 2 by 2 matrix which is given by 1 through 0, -1, and matrix B is given by 1, 0, -2, -1. And we are to determine whether these two matrices are similar by computations. We have proven in the first video that indeed A is similar to B, and we also shown that B was also similar to A. So now by computation we need to show that indeed A and B are similar. There is a meaning behind similarity when we talk about matrices. What we are saying is that if A is similar to B, it simply means that B is from A. And if B is similar to A, it means that A is from B. So this is what we are trying to show in direct computations, that indeed matrices A is similar to B. You can pause the video and try showing that A is similar to B or that B is similar to A, if you know how to figure it out. Otherwise, you follow us systematically as I take you through this matrix similarity. I remain your friend, Augustine Galagash, and if you are joining us in this video, click on the subscribe button in order to subscribe to this channel. You know you help us to help you as we continue to explore the main meaning of matrices similarity. Let us jump into it. In dealing with matrix similarity, the first thing that you might need to think about is that you need to know that PB, let's have P, B must be equal to AB, AP. So what we are simply saying is that we are going to introduce a P matrix, and that P matrix will be equal to some certain element A, B, and CD. A, B, and CD. This is a 2 by 2 matrix, just like what we have initially. We have this as a 2 by 2 matrix. Good. This is a 2 by 2 matrix in such a way that we multiply this AB, CD by the first matrix A. Our matrix A is given by 1 through 0, -1. So this will be that, this will implies that AB and CD, AB, CD, if we multiply this by 1, 0, then we have -2, -1, which is given as 1, 0, -2, -1. This is AB must be equal to AP. So we are looking for PB, and this is our P and this is our B, matrix B, and this must be equal to AP. So matrix A is given by 1, 2, this is 1, 2, we have 0, we have -1, -1. This is matrix A. Multiply this by P, and P is given by AB, CD, ABCD. Good. So this is exactly what we are trying to show, that our PB is equals to AP, and our P in this case is given as ABCD. So simply multiply A, B, C, D into B matrix and multiply ABCD into A matrix and see what that will give us. So if we do that, we simply have A minus 2B A minus 2B, and then this will be minus B. You can watch the previous video on where I did matrix multiplication, and this will be C minus 2D, and multiply this by, this is negative D. That is if you multiply these two matrices. Indeed, this will give you, if we multiply A by this matrix P, we simply have A plus 2C, then we have B plus 2D plus 2D. This will be negative C, and this will be negative D. It is simply, what we have done is matrix multiplication. You can watch the video on where I did matrix multiplication so that you know how to multiply two matrices. But when we multiply these two matrices, this is exactly what we get. Now we can solve this as system of equations, because here we are having a negative 2b. So if we solve this, this becomes negative 2b will be equals to 2c. What this implies is that our c is going to be equal to negative b. Our c is going to be equal to negative b. And then we will have c in this case will be equal to, or rather let's have c, this is negative 2b. Let's have c minus 2d to be equal to negative c. So meaning that d in this case will be equal to c, which is equal to negative b, because we know that c is negative b, and d here is equal to c because we have c minus 2d. So c minus 2d is equal to negative c, because we know that d is equal to c. And if that happens, we know what c is. C is simply negative b. So now we'll have negative b will be equal to b plus 2d. This implies that negative 2b minus 2d will be equal to, implies that d is equal to negative b. So we also have c here to be negative b. So this is our value for b. We have c to be negative b, and then we have d is equals to c. D is equals to c here. We have d is equals to c. We have this. C is equals to negative b, d is equals to c, and c is equals to b. Then another one we need to show is that d here is equals to negative b. So we can work with that now. Good. The next step now will be, having found the value of c, d, and b, we need to find the value for p. In this case, when we are looking for p, we know that p is given by a, b, c, d. So we simply need now to take the inverse of this. And what is the inverse of this matrix? The inverse of this matrix can be seen as 1 over the determinant of this into, let's switch this, it will become d, negative b, then we have negative c, and we have a. This will give us the inverse of this p, which is given by a, b, c, d. So what is the inverse of this? It will simply be a, b, negative b, negative b. this will be the inverse of the matrix that we have above, which is matrix P. So that now we will now have our P to be 1, 2, and negative 2, 2. And this is what we are given as matrix B. This matrix B now, we are going to look for the P inverse. The P inverse will simply be 1 over 2 divided by negative 2, like I have shown here. We have negative 2, 2 and 1. So that will end up with 1, 2, negative 2, 2, negative 2, 2, negative 2, 2. Then multiply this by the inverse, which is negative 1. This will give us we will have negative 1 also. We'll have negative 2 rows, multiply the rows by columns, and then we'll have negative here will be a half. So if we multiply matrix, we will simply get 1, 0, 0, 1. You can confirm with the previous video so that you know how to matrix multiplications. So what we have shown is that there exists matrix P, which we verified using matrix B, which was 1, 2, and then negative 2, negative 2, such that B, matrix B, is equals to P inverse of AP. And that is the idea of matrix similarity. We simply want to show that indeed matrix B is from matrix A, and matrix A is also from matrix B. So the first thing you need to do is introduce PB to be equals to AP, such that when you multiply some element A, B, C, D into B, you will get the same as A, B, C, D into A. And that is exactly what we have done in the first equation. And we are able to get our B, C, and D. Now we use the inverse of P in order to prove that indeed B is equals to P inverse of AP. You can go through it again so that you understand the concept and the concept and the logic behind matrix similarity. I remain your friend, Augustine Galagash.